Federal agencies operate under an intense mandate: integrate artificial intelligence across mission-critical operations, hit accelerated timelines, and execute within tight budgets. Meeting that mandate through speed alone creates a profound operational liability. There is a widespread assumption that making an AI system trustworthy is a compliance exercise, a checklist applied to a model just before it goes live. The reality is that trust is a strict structural architecture requirement. It must be engineered from day one for a system to function in a high-stakes environment. This creates a sharp divide in how modernization is executed. Organizations either adopt a tool-first approach or an architecture-first approach. To understand the difference, look at the existing infrastructure of most federal agencies. The environment relies heavily on fragmented, siloed data systems. On the left, the tool-first approach. When an AI model is hastily dropped onto disconnected infrastructure, existing connections fracture under operational strain. On the right, the architectural approach. A solid governance grid is established first. The descending AI node locks securely into the foundational intersections. When agencies prioritize the tool over the foundation, they generate technical debt, complex, undocumented workarounds that will require massive resources to resolve later. Treating AI trust as an afterthought guarantees system failure and actively degrades an agency's operational readiness. In federal digital modernization, the word trustworthy demands a highly specific operational standard. Commercial AI deployments are rarely designed to meet this standard. Federal environments require a significantly higher structural bar. This 3D model illustrates the first of 4 required pillars: explainability. Stripping away the opaque exterior of a standard model must reveal visible, comprehensible internal logic pathways. It is insufficient for a system's logic to be conceptually understood. Every decision must be mathematically traceable back to its source parameters. The second required pillar is auditability. An external pathway must constantly log the data flowing through those internal logic channels. This ensures total transparency during rigorous oversight audits. The third pillar is direct mission alignment, maintaining a rigid connection to a predefined operational objective. Finally, adversarial resilience. The system must deflect disruptive data and withstand operational stress without breaking its mission connection. If an architecture lacks even one of these 4 pillars, the integrity of the entire system is compromised. Unless explainability, auditability, mission alignment, and adversarial resilience are explicitly engineered into the foundation before deployment, trustworthiness remains purely aspirational. Despite these strict requirements, federal AI engagements still frequently fail. The most common cause is architectural rather than technical. The prerequisite for any AI tool is the establishment of governance scaffolding, the structural framework that controls how the tool interacts with agency data and processes. Agencies routinely procure and deploy AI tools before the scaffolding is built. In the tool-first architecture, an incorrect data point triggers a reverse trace that hits a dead end, lacking clear ownership. The error diverges chaotically, bypassing human oversight and corrupting downstream processes. Ultimately, the output detaches from its business purpose, collapsing into unmanageable technical debt. Leadership often sees the rapid deployment and mistakes this fragile implementation for successful modernization. Adopting an AI tool without an architectural map for error resolution degrades an agency's operational readiness and increases its vulnerability to systemic failure. The solution to this trap is enterprise architecture. It serves as the mandatory connective tissue between an agency's strategic intent and the AI systems deployed to execute it. Functional enterprise architecture is a process of dynamic structural engineering, not static bureaucratic documentation produced for its own sake. The tangled technical debt is replaced by a structured blueprint grid. This architecture enforces data provenance at the source, flowing clean data into the AI model. Clear ownership nodes lock onto the perimeter, and the output permanently tethers to a predefined mission outcome. This structure allows IT leadership to ask every AI vendor and integrator a definitive diagnostic question. How will we know when this system is wrong, and what happens next? If the answer is vague or the raid, the architecture is not ready for deployment. When enterprise architecture is properly utilized, an error instantly triggers an alert within the AI node and routes along a dedicated fail-safe pathway to a human oversight node based on strict predefined thresholds. Anticipating, catching, and routing failure with precision is the ultimate proof of a trustworthy AI architecture. Expanding our view from a single AI system to the broader federal digital infrastructure reveals the true scale of this requirement. The core of federal modernization is systemic trust. Success requires engineering accountability into the infrastructure itself. Agencies must invest in rigorous governance frameworks well before they purchase their first software license. They require verifiable data provenance and strict model accountability structures built directly into the foundation, and establish clear human oversight protocols from day one of the modernization initiative. The future trajectory of an agency depends entirely on whether they invest in this foundation. Organizations that rely on a tool-first approach will spend the next decade patching critical gaps instead of executing their mission. Trustworthy AI must be built and verified prior to deployment. It can never be successfully diagnosed after a failure has occurred. For CIOs, CTOs, and program executives, this establishes a clear mandate for mission traceability. Every deployed capability must map back to an operational objective. Treating trustworthy AI as a rigid, structural requirement is the only way to build digital modernization systems that actually last.